Hi, I'm Matt,
I'm Misha.
Myself, Shubham.
and in today's video, we're continuing our series exploring topics in cybersecurity for large language models. We've talked a lot about different types of attacks and how to use guardrails and other kinds of safeguards to mitigate those attacks. Last week, Shubham and Misha wrote a blog called How Safe Are Your Safeguards? And this is all about how to evaluate the effectiveness of safeguards. And it's quite important because we're really at the cusp of an arms race between attackers and defenders in this space. So you can imagine that you deploy a set of guardrails and it works today, but maybe tomorrow something new comes along. Maybe next week you deploy a different kind of safeguard. So you want some way to continuously evaluate these safeguards and make sure that they are still effective in the future. Shubham, do you want to tell us a little bit about how at Fuzzy Labs we've been approaching the evaluation of safeguards?
So evaluating these safeguards can be broken down into three components. So first would be collecting a dataset. Second would be comprehensive testing and validation. And third would be monitoring and collecting feedbacks.
Okay, that makes sense. So let's start with data collection. How do you collect that data set? Does it need to be specific to your project, for example?
Certainly. So there are different safeguards that cover various cases, and each of those safeguards have particular dataset that they are interested to cover it. So part of this process involves collecting and curating dataset across various diverse scenarios so that safeguards can be evaluated accordingly.
And the key here is that they need to cover the different kinds of safeguards that you might have in place, right? For example, you might have something that's detecting bad language, or you might have something else that's detecting whether the question being asked is on topic. And for each of those, you need different data sets to evaluate them. And what about the evaluation stage then? How does that look?
So the second component is comprehensive safeguard testing and validation. So in this process, we use the data collected in the first step and train a typical machine learning model, and then we evaluate this model on our test data set. So there is no one size fits all for this evaluation metric. Different safeguards prioritize different metrics. So in case of toxicity example, it might be we prioritize recall or precision so that we put a priority on detecting all the toxic prompts, sometimes usually flagging non-toxic prompts as toxic as well.
This should be pretty familiar territory, right? What we're really talking about is, for instance, if you have a model whose task is to detect toxic language, we're going to evaluate how well that model performs at the task on the dataset. And that's really just a kind of standard model evaluation that we might do in any machine learning model. And then the final stage is to improve, right? Once you've evaluated, once you've got a metric for how well your safeguards are doing, you want to use that information to make an improvement to the model. I suppose that the real takeaway here is that once you have these processes in place whereby you can evaluate the safeguards, you need to be able to run these in a continuous manner so that you know how well your safeguards are doing over a long period of time. I suppose you would update the dataset as well, right?
Yes, and that improved dataset can come from the last step, which is collecting feedback, where we can monitor how well our safeguards are performing and where are the loopholes that safeguards did not perform well on. We essentially create a dataset from these feedbacks and then continuously train our safeguards. So this creates a flywheel for a continuous evaluation approach for evaluating safeguards.
Fantastic. And as I say, this is the kind of approach that we use within Fuzzy Labs, but I think a lot of it is standard things that we're used to from the machine learning world more broadly. Misha, we've used this on a project recently in Fuzzy Labs, one where we are doing production grade large language models. Do you want to tell us a little bit about that? How did it work in practice?
In practice, there are many attack surfaces that we need to cover, and in this case study, we covered the off-topic question detection. Usually when we build LLM-powered applications, we only want the system to talk about specific topic. Off-topic modeling is a complicated task that can be achieved by multiple different approaches. Keyword filtering, we could use an off-the-shelf model for topic classification. We could train our own thing. We could use the LLM itself to classify whether the prompt is on topic or not. And all of those come with pros and cons. For example, keyword filtering is very simple to implement and execute, and it's very cheap computationally, but it can be easily avoided if the attacker knows that this thing is in place. If we turn into an opposite side of the spectrum, which is the LLM-based classification, there we have a very sophisticated system that can classify topics, but is susceptible to other attacks on LLMs. So we have an initial hypothesis that the attackers might attack our system in this way. We build the test set, we run the initial evaluation, we choose one of the approaches and we implement it. And then through using it and collecting feedback and monitoring, we might adjust how we approach this specific attack surface. For example, through testing the system, we realized that the LLM-based classification approach to off-topic modeling could be jailbroken, and it used significant computational resources. So at the next iteration, we switched to our own trained model. So this is where the monitoring, the continuous evaluation came in.
And it's enabling us to make decisions at the whole system level, right? Because as you point out, often it's going to be the case that we're combining multiple components to build our guardrails, and some of them might be models that we've trained, some of them may be models we've taken off the shelf from elsewhere. So there's also a need to evaluate the whole thing, right?
Yeah, it's often the case that we evaluate the safeguards individually and then we evaluate the safeguarding capabilities of the whole system too, because a lot of times these components are synergetic. So if something is not caught by one, it might be caught by another.
Fantastic. Well, Misha, Shubham, thanks very much. And if you'd like to learn more about how we approach evaluating safeguards on our projects, we'll provide the link to Misha and Shubham's full blog in the comments. And until next time, thanks as always for watching, and we'll see you in the next one. Bye-bye.
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 You know, when Shubham said myself Shubham, it threw me. I thought he had said something in Hindi, and then Misha no longer says Rastavatri.
We should each talk 3 different languages and let speaker figure out.
All right, I think I'll stop recording now. That will do. 20 minutes.
Press like and subscribe.
Like and subscribe.